Hello, my name is Peter Haumer. I'm a development lead at IBM working on a portfolio of offerings that we call IBM Wazi. Today I want to talk to you about ZOS development and the role of the developer. And with any way you want it, I mean really that to communicate that you have a lot of choices these days. Development for ZOS is not a totally green screen oriented endeavor anymore. It's really something where you have lots of choices in terms of how you want to do your development processes as well as what tools you're going to use. I will focus on Zowe and the fundamental platform it provides us to build IBM Wazi Developer, which is a portfolio of different technologies that I want to walk you through. I want to talk about this in the context of DevOps. The idea really of having an integrated development process that works for distributed as well as mainframe development using the same process, culture, and technologies. That is entirely transparent if you work either on a ZOS application or a distributed application. And the technologies and the choices that organizations are taking these days really confirm that. When we talk to customers and looking at analysis reports and the distributed as well as the ZOS development space, we can see these trends, right? So top technology investments around continuous integration, automation, containers, and then there are relevant tools for that, GitHub, VS Code, Kubernetes, as well as really the goal to move things into the cloud for various reasons I will talk about a little bit later, being able to really continuously deploy and integrate your applications as part of the DevOps culture and processes, and then heavily relying on open source and open technologies. And another motivating factor for all of this is this skills gap that you can see here, that 81% of the people ask have concerns with around the next generation of developers coming out of university, coming out of other jobs that expect a DevOps type of development environment in which the tools that they're used to can also be utilized for mainframe, which is entirely possible. And that's really the theme of this talk, right? So we want to look at development pipelines, as you can see here, and break down any of the silos for working and interacting with ZOS in that case. And for that, we have these three assumptions, right? So that ZOS has been transitioning to remove the differences that serve no purpose, meaning that you can use the mainframe just as any other node in your network and that you utilize for your development processes, and that many of the tools and applications are just available for the mainframe as they're available for the distributed systems. So open source works on ZOS or with ZOS, right? So open source can access ZOS. In particular, Zowe is playing an important role for that, but a lot of the things can actually also directly run on ZOS and can be executed from there. And then finally, that DevOps culture also works for ZOS development, that the same people do the same type of work using the same processes, that we're breaking down the silos amongst these cultures. Okay, so here are some examples for technologies that would fit the bill that we, particularly in IBM, are very interested in and exploring and utilizing, that we put into our portfolio, build on top of or build with, right? So there are many alternative technologies listed in here. By no means I want to suggest that everybody needs to use all of these things. It's just some examples that we dropped in here into this pipeline picture to give you an idea. In particular, in this talk, we're going to focus on the coding piece as I'm working on development tools, and so we will go into the area of build as well as even show you a little pipeline that performs CI/CD operations and bring these things together. I do want to spend a lot of time demoing many tools and solution components to you, but before I can do that, I want to just introduce you to the core underlying components that will appear in the demos in different various places, and also show you how they are layered on top of each other, how one piece builds on the next and makes the picture more complete, as well as where there are certain alternatives. So here I will first talk about what we've done for the Open Editor, but then you will see that solution components that we've created for the ZOpen editor have been reused in other places as well, such as a cloud-based editor, IBM Wazi for Red Hat code-ready workspaces, but also that some parts of the ZOpen editor come from the Eclipse-based tools that are also part of our portfolio, and then showing you how you have choices between these and how these tools do very similar things and are kind of interchangeable with each other, giving you those choices I was talking about, right? Developing in any way you want with the tools that you want. So let's start with these different layers and just quickly go through them for some of the principles, right? So one core underlying piece of technology that we heavily rely on is from the Zowe project, right? So you hear a lot of talks about the Zowe project at Share, so I don't need to go through the details what the Zowe vision really is, but one of the key technologies out of the Zowe project is called Zowe CLI, the ability to run command line operations from your local desktop, your Windows PC or Mac or Linux desktop that interact then with ZOS, allowing you to access your files, create data sets, and list your members, submit jobs, execute TSO commands, all through command line operations that you can use locally, that then create a connection with ZOS using various technologies, and then allowing you to take these commands and put them then perhaps into automation scripts that can be the baseline of some automation and pipelines that you're developing with it. And so Zowe CLI can be really a fundamental tool that you can do pure development on. So if you really just want to use the editor that you want, for example, your favorite editor is Emacs or VI I'm showing you in this case, you can use a Zowe CLI command to get a dataset member, perhaps a COBOL program that you download to your local Mac or Windows PC, edit it in VI, write it back, and then perhaps execute a JCL to build and test it. Right, so that's the most pure way of building things. But what Zowe CLI also is actually an SDK that tool developers can use now to build advanced functionality, as well as reuse many of these things to interact with ZOS. Using all the capabilities that Zowe CLI provides, but perhaps not as command line operations, but perhaps with graphical UIs, as we've done with the Zowe Explorer, that gives you a VS Code extension that gives you tree views to access MVS data sets, for example, utilizing the same code and connection information that you set up with Zowe CLI, making these technologies entirely compatible, interchangeable with each other. Zowe CLI itself is extensible, so you can write plugins for the CLI to provide special types of operations. And there are already in the Zowe project many popular plugins for Kix or DB2 and other areas that you can download and install and utilize following the same paradigm that Zowe provides. So then, speaking of this SDK and the ability now to reuse the Zowe CLI capabilities in a different way, right? So the Zowe CLI is cleanly architectured, separating like the business logic that interacts with ZOS through an API that developers can use and call, as from the actual command line parsing and operation. And this kind of separation also allowed Zowe now to publish what's called the Zowe SDKs. And so for Node.js and JavaScript, that was the first SDK available, but now it has also been implemented for many other different languages, and case tool developers can utilize those now for building integrations and tool features, as we've done here with VS Code and Node.js, as that's the main language you would use to extend VS Code, and created now graphical views, right? You can run CLI commands to give you the list of dataset members or the list of data sets and filter them, and so that's what we put here into tree views that basically call, as I mentioned, the same code, but give you now this ability to graphically access and manipulate within VS Code your files and perform the same operations that you could do with the CLI. So one layer on top of each other. And then another layer on top of that now with the Zowe Explorer, you have access now to ZOS. Now you get your COBOL or PL1 programs into a tool like VS Code, and now you want to edit this. And that's where the editors come into play. So the ZOpen editor is tightly integrated with Zowe Explorer, that when you then open your COBOL program, that you get full language support within the editor as you use with any other modern language, right? So in VS Code, people write Node.js programs and TypeScript or JavaScript or Java programs, PL1 program, Python programs, and so on. But you can now also do the same thing with other languages. And so the ZOpen editor is a free downloadable extension that will then co-install Zowe Explorer for the access to ZOS, and then provides language support for COBOL, PL1, high-level assembler, as well as REXX. And there are many tool features in there, such as code completion, syntax checking, and highlighting, looking up declarations and finding all references of variables or symbols within program code, and giving you an experience as with any other modern development language. That ZOpen editor is quite popular. We've seen 34,000 people have installed it since September 2019, and we can measure that we have, like within the last 90 days, 3,000 unique users. We have around 300 daily users who basically use this tool every day. We could see that this is distributed in many different countries and regions. So the editor became quite popular in the last year, and something you really can check out because it's completely freely available. You can directly get it from the VS Code marketplace. If you have VS Code installed, search for ZOpen editor and then click the install button to get it. And then you have language capability. So I will spend more time demoing this and showing you these theoretically here with slides. But the outline view you can see here. You can see reach hovers that show you contents of included files and many more features. For your reference, you will see key features and capabilities we have for COBOL and PL1. We added then also assembler around a year ago as another language to support, and then just recently we added the REXX language as another fully supported language that provides these capabilities that you see here too. Then the next layer on top of that was providing more integrations and more technology choices. And so what we've done is extending Zowe Explorer. Zowe Explorer was created around the Zowe SDK that was centered around ZOSMF, but the requirements were that perhaps some customers do not use ZOSMF. They might use FTP, or there are existing IBM Developer for Z customers and use RSE. And we wanted to enable those customers to utilize the infrastructure that they already set up and invested in, that they're familiar with using as well. Right? So what we've done then is to refactor the Zowe Explorer code to provide extensibility interfaces and extension points so that other extenders can plug in new protocols to be used for that. And so here's a vision how this could look like. So you would install the Zowe Explorer into VS Code that out of the box would support ZOSMF. And then we have an extensibility example where we implemented now the same APIs using the FTP protocol. There's a Zowe CLI plugin that you can install to execute command line operations using FTP as an alternative to ZOSMF. And then we did the same thing with the Zowe Explorer. The tree browsers can now access files through FTP and transparently use them. So as a user, you have the choice. You can use either or as you can see here, use them both at the same time. You create these profiles that define the connection to ZOS, and within the profile, you specify the type, the protocol that you're going to use. You say, here, I want to create a profile for ZOSMF, or I want to create another profile for FTP, and then you can use these interchangeably and perform the same operations. Right now, we have parity between the USS and MVS views between ZOSMF and FTP, and we're working on also doing this for JES views as well. And this FTP extension is also an extension that you can optionally install. Right? It's not something that's coming with Zowe Explorer. The idea really is to provide extensibility for Zowe Explorer itself. So it's something that you would install as a separate VS Code extension out of the marketplace that then plugs in and extends Zowe Explorer and its tree views with these new capabilities. And so this idea of making Zowe Explorer extensible then became quite popular for other use cases and other scenarios and other types of extensions. So we now formally are publishing an extensibility API that extenders can find on npmjs.com and create a dependency in their code to it, as well as even started work on conformance in the Zowe project, where extenders can then kind of certify that their extension follows the best practices that we recommend extensions to Zowe Explorer should follow. So this is currently under review. It's not approved yet, but the idea would be that that soon we can start a formal conformance program where you can then certify your extensions as fully Zowe compliant and conformant. And so one of these extensions then is that we wanted to accomplish as IBM was the Remote Systems Explorer integration. So if you use IDZ, IBM Developer for Z, you're familiar with the ZOS Explorer in there that gives you access and a tree view in Eclipse to access your MVS datasets, USS files, jobs, similar to what we've seen here in Zowe. And if you already have these servers up and running, then you can plug in just one more component on ZOS to get these REST API server that we're relying on. And then we've provided now another plug-in to Zowe CLI to perform command line operations entirely compatible with the command operations you would use for ZSMF. For every ZSMF operation, there's a matching RSE operation, as well as the extension to the Open Editor, Zowe Explorer, that would give you the graphical views. So in addition now to giving you views here that use ZSMF or FTP, you can now also utilize RSE if that's a technology you want to use instead of those others, as a full alternative that gives you all the capabilities that the other technologies have. There's even added value that we providing for our RSE customers. So with ZOSMF, you can already specify for your profiles page conversion mappings, right? Because when you load a file into VS Code, it gets converted to UTF-8. In VS Code, you added them as UTF-8, and then you write them back to ZOS to AppSedic. And so you need to specify when you load files out of MVS and what AppSedic code page they have been actually written and should be converted from. And so for ZOSMF, you can do this only globally for basically all your operations. For RSE, we're providing a more fine granular approach of giving you different levels of refining the mapping. So to an end, you can create mappings down to a file pattern level. So you can say for all the data sets that match this regular expression, this glob pattern, assume that the encoding would be IBM 273, whereas in other data sets, the encoding will be 1047. So giving you maximal flexibility if you work with multiple code pages, as well as want to distinguish your binary files from text files. So with these RSE specific extensions, we're giving you this flexibility to really trade one type of mapping specification on how you want to interact with USF, and then the tool would take care of doing the right and accurate conversions for you. Okay, so with the next two layers, I want to already compose now different pieces together. So with the user build layer, we want to talk about now how you can then use a build technology like dependency-based build directly out of the editors to run something what we call user build. So you as a user made some changes, you want to immediately try to build it locally before you then would commit those changes into your source code management system and start the full pipeline that might perform many other operations and might take longer. And so we want to enable you to do these types of things. Right, so if you're an IDZ customer, customer, you might be already familiar with dependency-based build, where we show you the workflow of how such a build works for the Eclipse-based tools, as well as now how the variant of this would look like with VS Code. Right, so the workflow you can see listed in here is for your reference, but I will actually perform such a workflow in the demo itself, so I will save some time in moving on in here. So what you will see me do in the editors will be a right-click operation on the COBOL program that I've modified, and then basically tell the editor, run a user build, and then we'll interact with ZOS and perform with DBB the build and give you the results back to the editor. All right, then finally, taking all these pieces together and moving things into the cloud. Why do we want to move these things into the cloud? There are various factors to consider, right? So the cloud transformation can drive more agility and speed of innovation. As you will see in the demo, deploying a development environment, development workspace can be something very fast and easy to do. If you figure it out for one developer, then you can perhaps use the same development setup for your other developers that you have in your team, right? One person creates a reference of all the tools and integrations that you need, describes these decoratively in terms of describing an image that describes the work environment, and that can be replicated in the cloud many times over. Just like how cloud technology is being used and in replicating transaction processing environments and so on as well, you can apply the same principles for the development environments as well. As you can see, we will even apply these principles and ideas on ZOS itself. As developers need their own development workspaces, they also need perhaps their own ZOS installation that they use for development. And here a technology called Wazi Sandbox will come into play that allows you to create in the cloud your own ZOS instance that's emulated, that you can use for development, and that allows you to scale up to and provide many installations and instances of these for your development teams. So the vision really is for IBM Z to be widely available within cloud and outside of the cloud, and support principles as containerization, self-service provisioning, Enterprise DevOps, lift operations, and to provide the cloud-native developer experience for IBM Z is our mission, right? That we want to provide a consistent and familiar environment to the next-gen developer that can then use the same principles, as I mentioned before, as with distributed development. So here I'm breaking down the different aspects and advantages of going cloud native, this idea of providing a self-provisioned environment, of providing your own ZOS instance that contains the tools and middleware that you need for your development process that you can control on, as well as then allowing you to scale up in terms of deploying and making development environments available to your team members in a replicable and repeatable way. So the product offering that we're utilizing here that uses all of those layers and components that I mentioned before, plus several others that I not cover yet as well, is called IBM Wazi Developer for Red Hat Code-Ready Workspaces, which comprises of these three main components. Wazi Code, which is a set of editors that I will show you around VS Code, Code-Ready Workspaces, as well as Eclipse. Wazi Sandbox that provides the emulator that allows you to run ZOS instances in the cloud emulated on x86 hardware, as well as Wazi Analyze, which I'm not going to cover today. There's a separate presentation to share with my colleague Gary Mazo about this that I will ask you to participate in instead. So overall, the user experience for DAP, the developer, the application developer, would be that she has a choice now. Does she prefer working with VS Code? Does she want to work directly in the cloud, in the browser, without any setup? Or does she want to use Eclipse desktop IDEs? Whatever she chooses, she can then access either out of these tools regular LPARS. using those Zowe technologies that I showed you, or transparently a sandbox. That's a virtualized containerized US environment that has all the same tools installed that you can also access with Zowe, and allows you to do the same tools such as debug, dependency-based build for her development jobs. Okay, so let's have a look at some of these tools now in a demo. So let's start the demo by giving the developer Deb access to her own virtualized US environment. And for that, we go directly here into the cloud. This can be on-prem or hosted or hybrid. And the idea is that you run Red Hat OpenShift, and within that you can deploy ZOS instances using the Wazi sandbox offering. So the administrator can easily provision and provide these by going into what is called the operator hub. And here, if you search us for Wazi, there will be two entries. One is the developer sandbox and the other developer for workspaces entry here. One allowing you to provision and install sandbox instances, as well as the other, the workspaces, the editors that I'm going to show you later. And so the idea really is that an administrator will initially set this up, provide the right images using ZDNT provisioning tools. They can create their own images that they want to use for this, and then deploying those into the cloud. Using the various deployment steps in here. So already prepared all of this, so there is an installation wizard that will guide you through this, and then various aspects of it need to be specified through YAML files in terms of configuring it. And that happens in the administrator view. As well as now the Deb would go into the development view and look at the various sandboxes being deployed in here. And so these sandboxes come with specifications now, as there can be many different sandboxes running in here of so-called port mappings. So I can see a quick overview here and drill down into the port mapping page. And now this was the sandbox that was created for Deb. And Deb will now find in this page the different ports she can use now to access this ZOS image. So there's FTP available in here, there's an SSH port, and the regular 22 number has been mapped now to 31.433. And so those are the ones that she can now configure together with the IP address of this sandbox to access this ZOS development environment for development. And of course, she can do this by using a green screen. So she found the port number that she's supposed to be using for this and the mapping file, creates a connection profile, and will be able now to connect with a host emulator and use it through there. She also has a choice now to use other tools such as Eclipse in this case. So here we have IBM Wazi Developer for Eclipse, version 1.2.5, the latest release. So if you know IDZ, so the Wazi Developer for Eclipse is a subset of IDZ. It's a subset of the tools centered around development with Git primarily, but has many of the tools that you're familiar with from the editing point of view and editing perspective. If you're an enterprise IDZ customer, you will also be entitled to the Wazi Developer and can use the same workflow to connect to your sandbox as well. So already prepared the connection in here, but we can look at the properties. So here now we've again took the ports that were listed and provided and entered them in here, provided the connectivity information, the username that we're using in here, and then be able to use the Remote Explorer now to access my data sets or my USS files that I'm later going to utilize here for the user build and start working in here, right? So I can open up my COBOL programs and I get full language support within Eclipse with various really sophisticated tools that allow me to many different things. So I have capabilities such as code completion in here where I can press Control Space and get choices of what to choose, but also tools that help me analyze my program. When I, for example, look at the workflow of some of my variables where they have been used, can right-click on those and do operations such as show these in the data flow hierarchy or the data flow view, first of all, which is a graphical view that will show me now how this variable is being used, as well as to the data flow hierarchy where the information is presented now as a navigable tree view in the same way as a graph was. Or I can look at the control flow of my operations and analyze things through there. Program control flow will show me here the position of the call graph where I'm currently at. Okay, so there are many more advanced editing capabilities in this editor, not only for COBOL but also PL1, Assembler, and also now recently added REXX. So let's have a look at if Deb would prefer to actually work with Microsoft Visual Studio Code. Then that's another alternative she can work with. So here I'm bringing up Visual Studio Code, and I have installed already various extensions in here. I got the Zowe Explorer 1.17. I got this FTP plugin to the Zowe Explorer that gives me FTP protocol support, and then the IBM Open Editor, which is installed here as well, which brings up this welcome page that lets you get started when you start out with this project for the first time, with this editor for the first time, and giving you pointers on where to start and finding the manuals and all those things. So the connection then to our sandbox is done in a very similar way, but this time here following slightly different UI paradigm in VS Code using the Zowe Explorer. So Zowe Explorer is another grouping in here, view group that we can use. And just to demonstrate the case, I've created two profiles in here, one using our sandbox with the OSMF. So there's a graphical dialog to enter or manage these connections. As you can see here, my cluster has been here specified with a port number that's been dedicated for ZOSMF, together then with the username I want to use, a password. If I have a self-signed certificate configured, if I use a Zowe mediation layer, that's also supported, and you can configure a base path in here. And those are the connections that I can now use to again bring up my data sets for this particular user I'm currently utilizing. And I can do this entirely transparently for both protocols. I can do it for ZOSMF, and just to show the point that this alternative RSE implementation gives you the exact same look and feel, and I'm retrieving the same data sets now for my sandbox. And I can add other connections in here, perhaps to physical LPARs, and can work with more than one system at the time, of course. In addition to datasets, there's also here support for USS. So here we have the ability now to specify the directory that we want to browse, bring that up, and then another view for jobs. So here I'm using that OSMF connection for my user, give me all my jobs, and I can expand here and look at spool files and so on. On the editing side, we have very similar editing capabilities that you saw in Eclipse. Just the user experience is slightly different and adjusted to the VS Code audience, but we do have an outline view that we can use to navigate around. We have similar capabilities of, for example, analyzing where certain variables have been declared or have been used. So I do right-click operations, peek on my references, gives me a little hover over here that shows me, allows me to navigate to all the different occurrences of using this variable, as well as some navigating to its declaration. I have refactoring operation to show you something new. So rename symbol. I can provide a new name of this a variable. And when you go back into the peak references view, you can see now that has been consistently renamed in all occurrences where the variable has been used. The whole thing is then fully Git integrated. If I save this, I can go to my Git perspective and bring up a change view, so I can see immediately all the changes that I've made here through my refactoring operations or any other work that I did. on this, and then I can commit this here, or in this case I just want to undo, discard all those changes going back to my previous state on that. So in addition to COBOL, as I mentioned, we support other languages. So here I'm bringing up now a PL1 program that has almost the exact same capabilities as the COBOL editor, including things like include file resolution that I have not shown you for COBOL, but works the same way. Here I'm including a file called balstat. I can preview the file, or I can follow the link directly. You can see it's in a parallel directory, and I can edit and navigate from here. Other languages are assembler. So we added the assembler language, which is also providing very similar capabilities that you've seen. So for example, code completion here shows you now all the different ways I can complete this operation, together with little hovers that explain a little bit to me what each of these operations are. If I'm a relatively new developer, I might not be familiar with all the variants of these operations, and those types of tools make you immediately more productive. And then finally, the latest language that we added is REXX support, which gives you similar capabilities, again, outline views, code completion, and so on. As you can see, these are powerful tools and give you a lot of capabilities. But as you saw in the beginning, there were various pieces that I had to install in here. So I had to install VS Code on my laptop. I had to then install these different extensions and configure them. The Zowe CLI is actually also available in here. So I can run Zowe commands, and I have also those plugins installed so that I can basically call RSE operations or FTP operations, but all of these had to also be downloaded and installed. Right, so you can have tools like Eclipse, which can like pre-package or provide different variants of packages that you have to download, but it often download a lot of things that perhaps a particular project or particular team doesn't need. Or in different approach with VS Code, we really document or provide packs of extensions that users need to download and configure. But in the end, developers have to take care of setting up their development environment. So one alternative way of doing this could be to pre-package these environments in what's called workspaces, and they are basically specified through declarative files that download things dynamically, as well as container images, and then in the cloud can be dynamically instantiated for every developer. So perhaps one developer creates a reference workspace template for a particular project as all the tools that all the developers of this project need, and then let's instantiate all the developers this then with one mouse click, which I want to show you next. So for that, we are back now in OpenShift in the administrative view, looking at our operators. So here I'm in a different project now than I was in for the sandbox. In fact, I'm actually on a different cluster here, but it's not really important. They can interact with each other. But here we have installed now the Wazi Developer for Workspaces operator. So the administrator performs this once, installs this platform and configures it in the environment, and then you can install more than one, but this is all access controlled, so you can create these different areas where different teams have access, configure their accounts, or link it up to an LDAP server for people to log on and authenticate. And then in the end, all he has to provide is one URL to the developers, which is this one here, that then every developer can open to go into the dashboard by first logging on. I was already logged on, so I was maintaining this, and then they will be able to create the so-called workspaces. So in the Getting Started page up here, there are already various workspace definitions provided out of the box for Wazi Developer. You can see we package a lot of different things into this workspace that the developers all get. So all I have to do now to create such a workspace is to click on this tile, and all the tools that you see here will be installed, particularly Zowe Explorer that we were using, as well as the ZOpen editor. So the exact same code base that you saw running in VS Code is entirely being used here. Right? Eclipse Shea code-ready workspaces implemented all the VS Code APIs so that regular VS Code extensions that you find in the marketplace workspace can run in here. So you have exactly the same capabilities available in VS Code as well as in this environment. And then you can see there are other technology and platform you can combine this with. So here we provide examples for Java, Node.js, C++, Go, and Python, right? So these are all languages that you can use on ZOS. Plus, this dashboard is entirely customizable. So if an administrator wants to provide different types of workspace definitions with different technology stacks for different projects in the organization, they can do this and add more tiles in here with different configurations. A developer can also create just a custom workspace. So the specification is done with these YAML files. So the templates you saw on the Getting Started page are available here in the drop-down, and then the specification for this workspace is pasted in here. And now the developer can go in and make individual modifications based on what they need for their particular work that they're currently doing. Then click Create and Open, and the workspace will be created. I already have one open and running in here so that I can just immediately dive into the demo next. As you can now see, here is the editor that was created and opened for my workspace that I'm using here. And I have almost the same user experience in terms of views as you saw in VS Code, right? The idea is really to be as familiar with VS Code as possible. You have the same keyboard shortcuts and menu items and capabilities, plus additional plugins and things working for you. So we can see here the regular file explorer with my COBOL program. The only small difference is the outline view is here on the right instead of on the left. And then the Zowe Explorer views in here, where I can again run up queries against MVS and retrieve my data sets and edit directly out of here, or use it out of USS or directly out of the file system. The choice is mine. But the key difference is here that all of these things are running in the cloud. I did not have to install anything on my laptop. Everything was configured with these YAML files, the specification of what tools to use, and then instantiated into various containers with plugins for different capabilities that this uses now to execute. And so once development team agrees on such a specification on what the workspace should look like, as I mentioned, hundreds of other users would be able to go in and work with that same environment without installing anything. Okay, being set up and running in here now, I want to just continue the capability demonstration, show you debug and various ways of running automation and builds out of here. And keep in mind again, all I'm showing you right now can also be done in VS Code as well as the Eclipse client, right? So the user experience of VS Code will be entirely the same with Eclipse client, just slightly different, but same capabilities. So let's start with the notion of debugging. For that, I can create a so-called debug profile that establishes a connection with my debug services running on ZOS. In this case, I'm debugging my application directly running on my sandbox that we are creating connected to from earlier. So I can create a new profile. I'm just debugging a little bash application that I have available. And you can see here was the address provided. This is part of my user settings where I can configure my default connection. I can also just type in here and modify that, fill in various options for the debug session, and then create the profile and then activate that profile. And so to be able to communicate with the server, I actually need to properly log on. So I configured my username as a default also in my user settings, and now I just need to provide the password to connect to it. And then you can see the green connection button available. And then you can start the debug session on ZOS as you used to do this perhaps from other tools with various ways. So one way we're providing with our examples is a JCL file that basically compiles and deploys the application and runs it so that we can debug it. So I can submit such a JCL directly here out of my Zowe Explorer and get a job ID back here that I can also, of course, check down in my jobs viewer if I want to, if everything's okay and that job is actually running. and so you can see a debug session being active here, and so then you need to have a debug launch, and so we're providing examples for it. So one launch where you can actually check now that there's a Park debug session for you available that you can connect to, and indeed the session is available. Now I can connect to it and be able then to look at the source code that was selected in here. So now I'll be able to go down and set a breakpoint. Just going back to this line that we analyzed earlier, and directly continue to this line. And then you will see variables can be explored in here. So I have now various abilities to look at variables and step through and see how they change and review the call stack and have really the debugging capabilities available that you're used to. Okay, let's just close this and look at other ways. So imagine now I'm a developer. I have to fix a bug, and I was basically asked to analyze a problem. I did a debug session. I figured out what the problem is, and now I want to do some changes. And so what I can do now is I'm in my master branch here. I can create a new branch out of it, 6 for the problem 1, just call it something like that, and branch out of this and can now start working on the files and make changes to it. Right, so I've analyzed my SAM program, just close some of these views, and I'll be able now to make changes in here. So let's just, I don't know, add a another display statement in here. Just for demo's sakes, add a hello statement in here and make changes. So assuming now I've basically fixed the problem, and I believe now that was the solution to my problem. What I can do now is run a user build out of this. So surely I can do another debug session and try things out as well, but I can also just run a user build. Perhaps I have already some Z unit tests available as well that I could run with this. And so this is done in 2 steps. So the first time we run a setup operation that will configure a directory that I've configured and in my user settings for containing my projects. It will upload various pieces for this particular files that I have in my Git repository, such as these application config property files that define various DBB settings that I need to configure this build. And then I can do a right click and do a IBM run user build, which then would execute the full build of the application, performing whatever I've specified in my Groovy program that's available also on USS. Right? So the workflow is really, you initially set up your user build on USS, you create your Groovy build file, you provide the workspace directories where everything should be built, you configure the editor by setting user settings on those directories, and then the idea is that once you actually do develop, you will be able to simply do right-click operations that will build your file from here, and then bring back reports and download them locally here into a folder. So I have a summary report that I can open directly here. That gives me, first of all, an overview report of what has been built with the dependencies, as well as then detailed log files that give me a full breakdown of the build, and I can basically check that everything was good. In this case, I also can here immediately see the build state, so this build was clean. So now I'm ready to share this with my team members. So originally this repository that we're using here with Git has been cloned from a GitLab project that we have here. So here's the original repo that I basically cloned into my workspace when I created my workspace, and I'll be able to directly commit and push my changes back from here with that. So I can review again the changes that I've made in here. That was a trivial one, but from here I can now provide a Git message, fix the issue, and commit that. Forgot to stage it, and now this has been committed, and now I can basically go in and push that back to the server. Then I can go back and look at my GitLab pipeline. So I can see there's one pending in here that was just kicked off for my fixed problem 1 branch, and you can see we've configured here a little automation script that performed very similar step that we did with the manual user build, but now basically this is being performed on the server. It can perform many additional things, can run additional unit tests and deploy jobs, and so it's walking now through the pipeline. And once it has been complete, I would be able then to go in and take my branch and create a merge request in GitLab for it, so that then my colleagues can review. They would see the build results, can review the logs, and merge then into the project after their review approval. So that concludes the demo that I wanted to show you. So just in summary, as I walk you through quite a large sets of different technologies and tools, an architectural overview of how these different pieces are fitting together. So we started out our demo by creating a sandbox that was running in Red Hat OpenShift, an individual sandbox or a developer dApp. And then first she connected to the sandbox, actually with the green screen, which we don't have here in the picture, but then the Wazi Developer or Eclipse, and was using Eclipse-based tools for editing. We then looked at VS Code and the editing capabilities in there, and then we switched over to the code-ready workspaces that we used also then for debugging and user build and kicking off a pipeline by pushing a commit to Git inside GitLab, and the GitLab CI was executing the pipeline, and Jenkins could have been another possibility of technology that can be used here as well. I hope you found this presentation useful. There are various ways of evaluating and trying these things out. A lot of the tools are for free. Also visit us on our GitHub page, particularly the github.com, IBM the Open Editor, about issues and discussion pages to provide us with feedback, and let us know what you think.